Hello and welcome to this tutorial. We're going to talk about the OSI model. Now, this is another reference model similar to the TCP/IP model that we discussed in the last tutorial. By the way, if you haven't yet checked out that tutorial, it's probably a good idea to pause this video now and to watch the TCP/IP model first, because in this one, not only are we going to talk about the OSI model, but we're going to compare and contrast the two, and we're going to rely on some of the concepts we covered already in that video. Alright, so the OSI model stands for Open Systems Interconnection, and this model actually predates the TCP/IP model. The OSI model came first. And just like the TCP/IP model, the OSI model dictates the rules of communications. This explains how different aspects of computing interact with each other. And in fact, this is where the standards are defined and referenced, so that everyone looking to participate in the game of communications can rely on this model to know how everyone else is going to work. In other words, this provides us a blueprint of how to communicate with each other. And the OSI model is very popular. It's often used in reference when discussing different components of networking and computing. Okay, so we're going to go ahead and check out the OSI model. We're going to look at all the different layers that compose the OSI model, and then we're also going to look at how it compares to the TCP/IP model. Alright, so let's go ahead and get started. So here is the OSI model. Now, the first thing to note about it is the OSI model is made up of 7 layers. And it starts at the top here with the application layer, and it works its way down to the bottom, which is the physical layer. So we're going to go through each one of these layers and figure out what they do and why we need them. But if you were to break this model into 2 groups to make it a little bit easier to comprehend, it would look something like this. The top 3 layers can be grouped together, and these 3 layers all have to deal with applications within a device. So how data is moved and communicated within a single device. So think about everything that might happen in a PC when a particular function is happening, when a particular application is running. Well, these 3 layers all deal with that sort of functionality. The second group has to deal with the bottom 4 layers. And when we group these together, all 4 of them have to deal, are concerned with the networking portion between devices. So in other words, how data is transmitted from one PC to another. Okay, so just a very broad stroke of cutting up this model to distinguish 2 different groups. Now, if we take a look and we'll bring up the TCP/IP model here, let's talk about how these two are similar. Well, obviously, the OSI model has more layers to it, but we're not really missing any information. And what I mean by that is the top 3 layers of the OSI model relate to the application layer of the TCP/IP model. Okay, so if you were to condense this group, it's all represented by just the application layer in the TCP/IP model. Now, the transport layer corresponds to the transport layer in both models. Likewise, the network layer of the OSI model corresponds to the internet layer of the TCP/IP model. In other words, they talk about the same things, there's just a different name on them. And then just as we had the grouping of the top 3 layers represented in the application layer in the TCP/IP model, well, here we have the bottom 2 layers correspond to the single network access layer of the TCP/IP model. So really, the TCP/IP model is kind of a condensed, shortened version of the OSI model. And just take some time to think about this when you're comparing and contrasting the 2 models in your mind. They cover the same stuff, it's just it's presented and represented a little bit differently. Alright, so with that said, let's actually go ahead now and take a look at each of the 7 layers of the OSI model. Okay, so the application layer is where we're presented with a user interface. In other words, this is where a human being will communicate directly with a computer. All right, so that's the first thing to keep in mind about the application layer. It provides a user interface. An example of that is, think about any program that you run, like a web browser, Internet Explorer or Firefox or Chrome. Well, those are applications, and those applications present an interface for you to interact with the computer. Now, the application layer also presents an interface to the applications themselves. In other words, an application, once you enter some data and then you hit the send button or you hit enter so that you can go to a website, that application then has to talk to the rest of the computer in different processes in order to make your wish come true. So in order to do that, the application layer defines, how it has to talk to the rest of the computer. All right, so not only is it an interface to you and me, it's an interface for the application itself to talk to the rest of the processes that enable it to communicate. Now, some examples of protocols that you'll find on the application layer are HTTP for going to websites, FTP and SNMP, and even voice over IP. All right, so those are the main characteristics and attributes of the application layer. Let's go ahead now and move one down to the presentation layer. Now, the presentation layer has a specific purpose, and its name kind of gives it away. Basically, the presentation layer presents data to applications, to programs running. In other words, the presentation layer will format or translate data when it has to go to and come from applications when an application is communicating. Because as you're going to see, when we go all the way down the stack in OSI Model, the data that's being communicated takes on different forms and different things are attached to it, and then eventually it's sent across a network to somebody else. So the presentation layer is like a personal translator for an application. Also, encryption is defined at the presentation layer. Not only that, but processes like compression and the decompression of data, those also happen at the presentation layer. All right, so when you think of presentation layer, think about how the data is presented or how it's delivered to and from the applications, and the presentation layer has to present it or deliver it in such a way that the applications can actually understand it. All right, so let's move on and take a look at the session layer. Now, with the session layer, we talk about how particular sessions are managed. In fact, the main purpose of the session layer is to manage or control the different sessions or communications, the conversations that an application might be having. So in other words, an application, let's say a web browser, you may have a couple different windows open to a bunch of different websites. Well, the session layer is going to go ahead and manage each one of those communications. It's like a different conversation, and the session layer will go ahead and be involved with the setting up of that conversation, managing it while it happens, and then when it's over, to go ahead and tear it down. So all the data that is sent and received during a particular conversation, the session layer makes sure that the right application gets it. Okay, so really the session layer is the conversation moderator. This is the person in the room making sure that the right people are talking to each other, and that if I'm talking to you, I can hear what you're saying and you can hear what I'm saying. All right? Now let's continue our track down the OSI model and take a look at the transport layer. But keep in mind, we just finished the top 3 layers, and these all have to do, like we mentioned, with the communication process within a particular device. Now we're going to go ahead and move into the second grouping, the last 4 layers, and that is where we start to get into the details of how that data is communicated or delivered between different devices. Now, the transport layer was also discussed when we talked about the TCP/IP model. And there isn't really much difference between the OSI model and the TCP/IP model when we talk about the transport layer. So here we're talking about the reliable or the unreliable delivery of data. This is where we start to get concerned with how data is going to get from one side to the next. We can also talk about error recovery happening at this layer. That leads us into the conversation of UDP and TCP. These are the two main protocols that are found at the transport layer. And just a quick overview, TCP is considered a connection-oriented protocol. It is concerned with the guaranteed or reliable delivery of data, and it also performs error recovery. Now, UDP, on the other hand, does not guarantee delivery. It is not connection-oriented, and it does not perform any sort of error recovery. In fact, it's meant as a very lightweight protocol for applications whose data is very sensitive to any kind of delay. Now, we have separate tutorials on UDP and TCP to flush out all the details of those, but for now, that's the overview of those protocols. And keep in mind, when you talk about the transport layer, we're talking about UDP and TCP. Okay, so let's continue and see how the network layer also is involved with the delivery of data. Now, the network layer is where we find logical addressing and routing. That means here we talk about IP addresses. This is where it's defined. And IP addresses, as a quick overview, is a way to give an address to a device. And that device could be anywhere in the world. And if I want to send data to it, I need to know that address. Now, the routing portion comes in because if you know an address, you need to know how to get there. Well, routing is also defined at the network layer. And the primary protocol which is involved with the IP addressing and the routing is IP, or the Internet Protocol. The primary devices that are involved at the network layer are routers. So as a network administrator, routers and switches are the primary devices that one usually works on. So this is where we start to see devices that we'll become very familiar with, where they fit in on the OSI model. Now, that doesn't mean that routers are ignorant of the transport layer or the session layer, however, or the data link layer. However, if you have to define their primary purpose, it would be here at the network layer and with IP. So related to this is the data link layer, and let's go ahead and take a look at that next. Now, the data link layer is where we start to talk about how we actually access the physical media. In other words, we have this data coming down all the way from the application, working its way through presentation, session, transport, and network. Now we're at the layer where all of that is taken and it's put into a form where we can actually access the physical media that we're working with and deliver that data. So here we have things like the protocols used to run on the physical media. We talk about how frames are created at the data link layer, and those frames kind of define the format of the information and how it's going to be sent along. And also we talk about hardware addressing. And when we take the deep dive into Ethernet, we'll talk about MAC addresses. One of the services delivered at the data link layer is error detection. Now, the error correction is not handled here. That's handled at the transport layer with TCP. But error detection, very simply, did an error happen when this data was transmitted or not? That functionality can happen at the data link layer. Some of the protocols that we find at the data link layer are Ethernet, very common on local area networks. And then we find other data link layer protocols like frame relay and HDLC, and we find those in wide area networks. Okay, so when you think about the data link layer, think about getting the information ready to access and be put on the physical media. And that only leaves us with one more thing to talk about, the physical media itself, and that leaves us with the physical layer. Well, at the very bottom is the physical layer, and here we're really concerned with how the bits are really just sent and received, how it's literally done on the physical network. So that means we talk about things like the cables and the different connectors used. We also talk about voltage and electrical currents. This is the physical transmission of the data itself. After it's come through all these different layers, here is where, the tires meet the road and the data is actually sent along. So some of the standards that come up at the physical layer are in fact Ethernet, because Ethernet not only handles the data link layer, but it also defines some of the physical aspects of a network. And then there's also another example here, like an RJ45, that defines a particular connector. Okay, so at the physical layer, we're talking all things physical. Kind of simple to remember in that respect. All right, so that is the last layer of the OSI model. Let's take a look briefly at some of the reasons why we want to use this model. Now, these advantages or benefits of using a model are the same as those we talked about when we discussed the TCP/IP model. In other words, as consumers, we get some comfort in knowing that different vendors of the same type of equipment will work together. So you can have a Cisco router and a Juniper router, and we know the expectation is there that they are going to work together because they're based upon the same blueprints or the same models. There's a huge benefit to that, because as a consumer, I know that I can buy either one. I'm not locked into one vendor over the other. And if you consider how big the internet is and how many different types of equipment are on the internet, if they did not work well together, we could not have such a great global network. That means we're creating industry standards. These models help us define the standards and are referenced as a standard. So again, we have a common point of reference when we're talking about technology and when we're actually implementing the technology. One of the biggest benefits is we're taking a relatively complex subject, like two PCs talking to each other and they're located halfway around the world. Well, if we're talking about a particular problem we're trying to fix, or we're talking about a particular characteristic of how they communicate, we can go ahead and locate that within a particular layer on a model. That way we can more easily get into the details and discuss with other people what exactly is happening. So we're breaking it down into something more manageable for us to talk about. Because really, these are very complex processes, and there's a lot of information, a lot of protocols, a lot of standards to talk about in the entire process. So cutting it up into smaller pieces, more bite-sized pieces, if you will, just makes life a lot easier. Finally, when we talk about development, we know that we can work on a particular layer of the OSI model without interrupting other layers. So this modular effect is very beneficial because you're not disrupting the entire stack or an entire piece of equipment. You may be focusing in on a particular layer, and by doing that, we have a lot more flexibility and versatility when it comes to developing equipment and standards and protocols. All right, so these are the benefits. So to summarize what we covered, there's a lot of information there. And the best thing I can tell you is you just simply need to memorize the OSI model and the TCP/IP model. Know the names of each layer and know the function of each layer. Now, if we talked about any protocols being present at a particular layer, just be familiar with them. Some layers have many protocols. You don't have to memorize all of them right off the bat, but just start to get more and more familiar. And if you see a protocol, try to place it at a particular layer. And finally, knowing the order of the layers is just as important as knowing the names and the functions. There are a lot of different tips and tricks as to how to commit these to memory. Find one that works best for you. And this is not just an academic exercise, because as you start to learn more and more about networking, this model actually helps you not only understand more in-depth technologies, but also it's very useful in the field when you're troubleshooting and talking to colleagues. Okay, so that's it. That is the OSI model. Thanks for watching.